Welcome back to High Tech Heroes. I'm talking with Superprogrammer Mark Rustad here about computing in the old days in Minnesota. And you're about to tell us about when they got a UNIVAC?
That's correct. MECC purchased a UNIVAC to serve the needs of education all over the state of Minnesota. It was intended to be a very large-scale time-sharing system with, I don't even remember how many hundred ports.
So the state of Minnesota decided that they wanted their kids to be able to program. Of course, Minnesota's where Seymour Cray is from, right?
That's right.
So they wanted to have, I guess, the state stay ahead in computing, and they were going to make it available to all the high school kids in the early 70s?
That's correct, yeah. This got started around 74, I believe. 73 or 74.
Okay, and they bought a UNIVAC computer to serve the whole state, and we're going to put networks over the whole state.
Right. They had a statewide network so that very nearly every school in the state had some sort of access to the system.
Including colleges, or just?
Yeah, especially colleges.
Okay.
But all the way down to elementary school.
And that sounds like a great idea. Did it work?
Well, it was good in principle. Not such a great computer for that use, though.
And why was that?
Well, although it lived up to its contractual obligation, which was 90% uptime, the contract hadn't specified a mean time between failure, and the mean time between failure at times was measured in minutes.
Minutes. So what you're telling me is you'd sign on to this computer. I guess you'd wait for it to crash. Then when it came back up, you'd sign on as soon as you could, and you'd log in and get a little past login sequence, and it'd go down again.
That's basically right.
Well, that's
but fortunately, it would generally recover in just a few seconds, so it still maintained 90% uptime, even though nobody could practically get any work done.
Well, that sounds like meeting the letter of a contract, but not necessarily the spirit of the contract.
That was the way a lot of us saw it.
So what did you do about it?
Well, a lot of things happened. Early on, we called in frequently to report problems, and we found quite a lot of problems.
Meaning that you found bugs in their system and tried to debug their system for them?
Well, we certainly found a lot of bugs in the system. And we called up and would attempt to tell them about the bugs and how to reproduce them so that they could fix them. And we always got the same answer from the other end of the phone, that no, it doesn't work that way, that doesn't happen, you can't do that. And
so they basically weren't interested in improving their product.
That was our conclusion. And so after a few dozen attempts like that, we decided that they really didn't want to hear about it, and so we stopped telling them.
Okay. And then what?
Well, it doesn't mean we didn't stop finding bugs. The system was just riddled with them.
What are some examples of some major problems?
Well, even innocent students would crash the system. They'd come in and type in their Fortran homework, and some bug in three-dimensional array indexing in Fortran would crash the system. And the poor student many times didn't even realize that they had crashed the system. So they'd come in every day and try their homework again and crash the system every day and never get their homework done and not understand why.
So basically, you were a student in Minnesota and you were stuck with a computer system that didn't work after having used the 6400, I guess.
Right. The University of Minnesota system was quite reliable.
So what happened to fix this problem?
Well, a group of people all over the state, and a few of us in Moorhead, kind of ganged up on the UNIVAC a little bit and tried to make it fail its contractual obligations. I
see. And were they successful?
I believe one way of interpreting the outcome is that we were successful.
Well, now, they must have measured this on a particular time or something. What happened when the state went to measure this? I mean, it seems like they would have to have some acceptance date or something.
Right. It passed its acceptance. But what happened is the quality of service was so poor that school administrators all over the state were dropping the service, cutting back, because it really wasn't working for them. And in fact, one district bought Altair microcomputers because they felt they were much more effective than the statewide time-sharing network. At that time, I'm certain they were right.
And wasn't there something that they did to check the performance? What a special story that happened on a certain day?
That's right. To attempt to load down the computer, they actually sent a message out to all the teachers in the state to let their kids out of class at a particular time so that they could maximize the load. it turned out that day we had gotten the password to the sys$dloc file.
Now, how do you happen to get a password to I don't know what sys$dloc is, but I assume this is like the high chief password or something. This lets you onto the
It
everything
opens
in
all the
system.
doors.
Uh-huh.
Opens all the doors. And we had gotten it by just wading through stale disk data. The UNIVAC system essentially didn't prevent you from doing that, and so we...
So you're telling me if you use a sector on the disk drive or a file, you delete it, it changes a pointer in the directory, it leaves all the data on the disk, you go out and get it.
Right.
You create a file and it's already in your file.
That's correct.
Okay.
And you find interesting passwords doing that.
So you found this sys$dloc password.
That's right.
Okay. And then what?
Well, since they wanted to maximize the load on the computer, I decided to help them a little bit. And so I wrote a program that requested the highest real-time priority in the system and then infinitely looped. The system had 2 CPUs, so that I knew this wouldn't be a fatal problem.
Okay, so you only used up essentially half of the computing resources for the whole state.
Yeah,
But only on the time they were going to measure it to see how.
That's correct,
what its
yeah.
performance
I was a 50% load factor that day. The operators down the computer room kind of noticed that something had happened because all the lights on one CPU froze, and they didn't know why.
Oh,
And they thought that this was a bad thing, and they ought to find out what happened. So they took the system down at that point.
So they took the system down during the middle of this measurement.
That's correct.
Oh, okay. And then?
And well, earlier in the morning when we got the password to the sys$dloc file, we changed it because it was too hard to type. And we had forgotten that we had changed it because that was hours ago by this time. And when they took the system down, they were unable to bring it back up because they didn't have the password anymore. And since we had been troublemakers in the past, they knew to call Moorhead State. Mm-hmm. And the head of the computer science department came in and asked us about something about a password. And about that time, we remembered what we had done. And oh, yeah. So we gave him the password, and the system was back up in a few minutes. I have heard that it would have taken 4 to 6 hours to get the system back up any other way.
Well, did the state then get the message that this wasn't that this machine didn't perform very well?
Well, they got the message when people were dropping service because of its poor reliability.
I see. But they were still bound by the contract.
That's correct. But since they were unable to pay for the machine with the reduced service levels, UNIVAC wound up canceling the contract. Because the contract was, I believe they paid on a per-user basis. So as the users went, the payments to UNIVAC got smaller.
Oh, well, that at least gives some feedback.
Yeah.
And what happened? I guess eventually they lost the UNIVAC. And
yeah, eventually the UNIVAC was removed, and they went out for bid on a smaller time-sharing system to replace it, because now the load was so much less.
Uh-huh.
And CDC won the bid on that contract.
With another small computer or a large computer?
Well, still a large computer, smaller than the 1110. It was a Cyber 73.
Which is really a 6500 by my way of thinking.
Yeah, same thing. Different color
so
skins.
It's a dual CPU 6400 and quite a powerful machine.
That's correct.
And how many stations or how many terminals could that run?
Well, it started off with around 300 and was supposed to grow up to, I don't remember the exact number, around 400 over a 5-year period. Within 3 years, we had expanded to 448 ports, which was more than anybody at CDC thought that machine could handle.
448?
Yes.
So that's the largest time-sharing system for that size machine that I've ever heard of, and I used to work on those machines.
CDC didn't think it was possible, but we did it.
And it's not special interpreters or anything, it's general-purpose time-sharing.
That's correct, yeah. People were compiling, in fact, every basic program run on the machine was actually compiled to machine language and executed.
So what did you do when you graduated from college?
Well, I worked for CDC for a brief time and then wound up working at MECC as a system programmer.
No. You wound up working at the place that used to crash their computers all the time?
That's right. It was an interesting job interview. Mm-hmm. They were about to install the Cyber 73 there, and I remember discussing with my future manager a bug in the CDC operating system that would allow anybody with access to 2 terminals to hang the system indefinitely.
And I guess they hired you because they wanted to fix this bug.
Yeah, CDC fixed the bug, but still it was interesting.
So what else did you do while you were at MECC?
Got involved with a lot of things. Wrote an electronic mail program. Actually had been doing that off and on for quite a while, but this was a pretty high volume one since it was the main mail program for the system.
And what else did you write while you were there?
Lots of operating system modifications. We did a multi-user subsystem that would allow essentially a form of transaction processing, but the transaction processor could be written by anyone, even in a language as simple as BASIC. So
you wrote something, a multi-user BASIC, which would allow, now could I like write a game and have people play against each other inside this
certainly
this program? Oh, so it's re-entrant or it's
shared code.
Shared code.
Shared code and some shared data.
That's very impressive. That's very impressive. So what do you do now?
Well, I'm with Apple Computer now, working on networking and communication software.